Okay, so decimal addition and subtraction are pretty easy. Let's move on to something a little harder, decimal multiplication. Now, as you know, multi-digit multiplication is more complicated because there are so many multiplication steps. But the good news is that decimal numbers don't really make the procedure much harder than it is with whole numbers. That's because there's a clever way that we can make decimal multiplication look exactly like the multi-digit multiplication with whole numbers that you already know how to do. The key is to pretend that the decimal points are not really there. Hold on a minute. I mean, I like pretending as much as you do, but if we just pretend that the decimal points aren't even there, we aren't going to get the right answer, are we? Well, no, but the only thing that will be wrong with the answer is that the decimal point won't be in the right spot. So we'll need to fix that at the end. I know it sounds a little confusing, so here's an example that should help you understand. I knew you would say that. Let's say that you need to multiply 3.65 by 2.4. Now that seems a little tricky, but what if we just pretend that the decimal points are not there for now? In other words, what if we pretended that the numbers were 365 and 24? You already know how to do that problem. You would just follow the procedure that we learned in multi-digit multiplication, part 2, and you'd get the answer 8,760. But that's the answer to 365 times 24, not 3.65 times 2.4. So it's time to stop pretending. To get the correct answer for the decimal problem, we've got to understand what's going on with those decimal points and why we just pretended they weren't there. The truth is, when we pretended that the decimal points weren't there, what we were really doing is pretending that they had been shifted until both of our numbers became whole numbers. Remember, the numbers 365 and 24 technically do have decimal points. They're right there next to the ones place. We just don't need to show them since there aren't any decimal digits. So, by ignoring the decimal points, what we were really doing is mentally shifting the decimal points to the right. We shifted the top decimal point 2 places to the right, and we shifted the bottom decimal point 1 place to the right. But doing that changed the numbers. It made the top number 100 times bigger than the decimal version, and it made the bottom number 10 times bigger. That's because every time you shift the decimal point 1 number placed to the right, it's like multiplying by a factor of 10. And that means the answer we got is way too big. It's too big by 3 factors of 10, because the decimal points in our problem got shifted a total of 3 places to the right, 2 on the top and 1 on the bottom. So to fix that, we're going to have to shift the decimal point in our answer the same amount in the opposite direction. In other words, we need to move the decimal point in our answer 3 places to the left, which will make it smaller by 3 factors of 10. So, starting right here, where the decimal point would be if our answer was 8,760, we shift it 3 places to the left, and we end up with 8.760, or just 8.76. And that is the answer to 3.65 times 2.4. That's a cool trick, huh? It means that you can do decimal multiplication just like regular multi-digit multiplication. You start by setting up your multiplication problem exactly like you would if the decimal points were invisible. But don't just erase them, because you'll need them at the end to figure out how many places to shift the decimal point in the answer. Then, keep ignoring the decimal points while you follow the multiplication procedure. Once you have an answer, count up how many places the decimal points are shifted in the problem you're working. Don't forget, it's the total shift of both the top and bottom decimal points. And then